All right, in Unit 11, we talk about two basic ideas, prime and composite numbers. And then if a number isn't prime, it means it's composite, how do we factor it? So that's what we want to talk about. Now to begin with, we start off with some divisibility rules. How do we know that a number can be divided by 2? Well, any even number can be divided by 2, and so we can recognize those numbers by what they end in. They'll end in a 0, a 2, a 4, a 6, or an 8. And so divisibility by 2 isn't bad. Divisibility by 3 is a little different. Turns out that if you take the individual digits in a number and add them up, and the result is divisible by 3, then the number itself will be divisible by 3. So for instance, is 39 divisible by 3? Well, how we test it is we take 3 plus 9, which is 12, and since 12 is divisible by 3, 39 will be divisible by 3. Okay, how about a bigger number, like 438? Well, again, we take those individual numbers and we add them up. 4 plus 3 is 7, plus 8 is 15. Since 15 is divisible by 3, yes, 438 will also be divisible by 3. What about 2029? Well, if we add those up, now I don't need to add the 0. Add those up, I get 13. No, 13 is not divisible by 3, so no, that number won't be divisible by 3 either. All right, so we're worried about divisible by 2, divisible by 3. The other one we're worried about is divisible by 5. How do we know if a number is divisible by 5? Well, it turns out if we think about multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40, all those numbers either end in a 0 or they end in 1. Or sorry, 0 or a 5. So, can you tell if they're divisible by 5? Well, they got to end in either a 0 or a 5. So, here's a typical question that we would give you. Given these numbers, how do I know? How do I identify the numbers that are divisible by 2? Well, let's start there. If I look, I'm looking for numbers that end in 0, 2, 4, 6, or 8. So 7 doesn't fit, but 14 certainly does. 18 certainly does. 24 does. 30, yeah. 130. Now 147, no, that doesn't end in an even number, and neither does 291. So these are the numbers that would be divisible by 2. All right, so let's do divisibility by 3. So I'm going to be adding those up, right? Well, 7 isn't divisible by 3, so number 7 isn't. 14, 4 plus 1 is 5. No, that doesn't work. 1 plus 8 is 9. Yeah, 9 is divisible, so 18 must be. 24, well, you either know that that's 3 times 8, or you'd say, well, 2 plus 4 is 6. 6 is divisible by 3, so 24 is. 30, well, yeah, again, 3 times 10, or if you add them up. Now, how about 130? Well, if I add those up, 1 plus 3 is 4, plus 0 is still 4, so no, it's not. And now we start getting into bigger numbers, 147. Well, 147, when I add that up, 1 plus 4 is 5, plus 7 is 12. 12 is divisible, so 147 will be divisible. And lastly, 291. When I add that up, 2 and 9 is 11, plus 1 is 12. Again, divisible by 3, so 291 is divisible by 3. So, lastly, divisible by 5. Well, now I'm looking for numbers that end in 0 or 5. The first one that ends in 0 is 30, and then 130, and if I look, none of them end in 5. So those would be the numbers that are divisible by 5. So, now, our definition, a prime number. A prime number is a number that is only divisible by itself and 1. So, by definition, 1 itself isn't prime, but 2 is, 3 is, 4 isn't, because 4, besides 1 going into 4 and 4 going into 4, 2 also goes into 4. So it turns out none of the even numbers after 2 will be prime. So really we're looking for odd numbers, like 5, 7. Now 9 doesn't fit, because 9 is 3 times 3. 10 doesn't fit, 11 would, 13 would, and so on. These are all examples of prime numbers. Now, composite numbers are numbers that are not prime. So numbers like 4, 6, 8, 10, 12. Oh, I missed one. I missed 9. Let's go back and put 9 in there. 9, 10, 12, 14, 15, right? Those are all examples of numbers that are composite. So here's a list of numbers. How can I tell which ones are prime? Well, again, I look which ones have factors other than 1 in itself. Well, 3, it turns out, is prime. 5, only divisible by 1 in 5. But 6 is divisible, 2 goes into it, so 6 is a composite number. 9, well, 3 goes into 9, so 9 is also a composite number. 11, the only factors that 11 have are 1 and 11, so it would go here. But 15 ends in a 5, so it's divisible by 5. 15 would be a composite. 17 is a prime. 23, when I add that up, 2 plus 3 is 5, so it's not divisible by 3, not divisible by 5, not divisible by 2. Turns out that 23 is composite. 37, hi. Okay, let's continue with 37. 37 is one of those bigger numbers. If I add 3 and 7 together, that's 10. That's not divisible by 3. It's not divisible by 2. It's not divisible by 5. And again, if we were to keep searching, we'd find out it's not divisible by anything other than itself and 1. So 37 is also prime. Now, so I want you to know the difference between prime and composite. I also want you to be able to factor some numbers then. So if I ask you to find the prime factorization of 20, often what we do is we do it in a couple different ways. We can do what we call the factor tree, or we can just start dividing. Since this one ends in 0, I would say, hey, 5 goes into that. Now 5 goes into 24 times. Now 4 is even, so 2 goes into it, leaving me at 2. Now 2 is prime, so the only factors are 2 and 1. So we would say the prime factorization of 20 is 2 times 2 times 5, or we'd often write it using an exponent, 2 squared times 5. Okay? Now, let's do a little bigger number, 312. That one's going to take us a little bit of work, but notice it ends in a 2, so right away I know that 2 goes into it evenly. So if I do that, oh, let's put that down one. 2 goes in there, and I do the division. Oh, yeah, put it back up here. 2 goes into 3 once, carrying a 1, that's 11. 2 goes into 11 5 times, carry 1, 6. Okay, still ends in 2, so let's put 2 in there again. 2 doesn't go into 1, but it goes into 15 7 times, leaving a 1, 16, 8 times. Okay. Now, it still ends in 2, so do that again. 2 goes into 7 3 times, carry 1 is 18, 9. And again, if you have to do that off to the side, take it, do it off to the side, do your long division, right? All right, no longer ends in 2 or 4 or 6 or 8 or 0, so 2 doesn't go into it. Add those up, I get 12. 3 goes into it. So 3 divided by 3 is 1. 3 goes into 9 3 times 13. 13 is prime. So there are my factors. So if I was going to write it out in expanded form, 2 times 2 times 2 times 3 times 13, or often we'd write it out in exponential form, 2 cubed times 3 times 13. So when we want it in fact be in factored form, prime factorization, this is the form we'd be looking for. And usually we'll ask you to write it using an exponential form. So use your exponents to write that.